Hello everyone. Thank you organizers for having me. My name is K. Rohit and I would like to acknowledge my co-authors K. Karan Sai, MV Sai Teja, T. Deepika and our guide Sahana Bano ma'am for aiding us through this research. Today I am going to talk about implementing spot the differences game using Yolo algorithm.
The requirement for object detection has been expanding with computational force. Object identification is a technique that identifies the object's class present in the image or video. In this work, we talk about implementing an application that connects with the user and distinguishes the various objects. The user collaborates with the application through speech and recognizes the image.
Object detection is one of the most generally utilized tools in computer vision. The natural eye can recognize objects to a wide reach. However, carrying that ability to a computer is a difficult task. Object detection is utilized in many fields like self-driving vehicles, video surveillance, and many more. The principal thought of object recognition is to recognize objects and arrange them accordingly. There are few algorithms for object recognition. These are isolated into two kinds, mainly classification and regression. Our main aim is to implement an application that distinguishes differences between two images utilizing Yolo algorithm. Here comes the question why Yolo is used in this research. Yolo is having a good balance between speed and accuracy. There are many algorithms, but the reason for picking Yolo is its speed. The biggest advantage of Yolo is its super speed, and it's incredibly fast and can process 45 frames per second. Yolo also understands generalized object representation. It outperformed other detection methods including DPM and RCNN. Due to Yolo's generalizability and applicability with wide range of domains and unexpected outputs, it is considered as one of the best algorithms for object detection. Yolo is having different versions. Among those, the predominant versions are Yolo version 2, version 3 and version 4. All these versions are pre-trained with 80 objects. Yolo version 2 is mostly used for object detection in images, but version 4 is very useful in detecting objects in videos. Yolo v3 and v4 can draw 10,000 plus boxes, whereas version 2 is only limited to 845. Coming to the frame rates per second, the Yolo v2 can draw up to 40 to 90 frames, whereas version 3 and version 4 can draw greater than 90 frames. The time taken for object detection in Yolo v3 is 439 milliseconds and can identify 16 to 17 objects at a time. Time taken for identifying objects in Yolo v4 is 715 milliseconds and it's only limited to 16 objects. The Yolo v2 comes under Darknet 19 framework as it is having 19 convolutional layers. Yolo v3 comes under Darknet 53 as it is having 53 convolutional layers for detecting 53 more added, making 106 layers in total. The smaller size object detection is best in Yolo v2, but the Yolo v3 is far more better than v2. How Yolo algorithm works. Yolo is the short term of you only look once, an object detection algorithm used to distinguish and identify different objects in real time. As the name recommends, it runs just a single time through the whole image. Yolo algorithm predicts the class probabilities and bounding boxes of the objects present in the image. Yolo algorithm uses neural networks to provide real-time object detection. This algorithm is popular because of its speed and accuracy. It has been used in various applications to detect traffic lights, people, parking meters, and animals. It is also used in many industries. In Yolo, every image is converted into cells or grid-like structure as shown in the image. Yolo algorithm draws the bounding boxes based on these parameters. Bx and by to know the center of the object, bw to know the width of the object, bh to the height of the object. Yolo algorithm generally predicts more than one bounding boxes as it generates more probabilities. Then how come these bounding boxes are reduced to 1? This is done by non-maximum suppression. Non-maximum suppression. Objects sometimes tend to get detected more than one time, resulting in more than one bounding box. This can be resolved using non-maximum suppression, which suppresses the bounding boxes with non-maximum probabilities. In the image, the Yolo has drawn more bounding boxes, but by using the non-maximum suppression, it is reduced to 1. This reduction in bounding boxes is done by the confidence values of each box that is predicted by the Yolo. Hence, now we know how Yolo algorithm works
Now let's try to understand how Yolo is applied for predicting spot the differences game. Before that, we look into data that we created for implementing the game. As it's already known that Yolo is pre-trained model with 80 objects. So we collected individual images of truck, bus, skateboard, bike, etc. We grouped these images into single image as shown in the image. We also collected the images of animals like dog, elephant and horse. These pictures are later given to the model for identifying them separately in every image. The main aim of our work is to implement an application that recognizes the different objects present in the two comparative images. The user communicates with the model through speech module. In the speech module, we have used PyTTSX3 module, which is named as Python Text to Speech Converter. It is mainly used to convert speech to text. First, the speech module is taken to take the input from the user. The system elaborately shows two comparable images with a couple of differences. It additionally distinguishes the objects present in the images. Now the user recognizes the various objects present in the images. The information given by the user is checked by the model and displays the right answer. A bounding box is drawn to indicate the area of the subject. The bounding box is only drawn if the right answer is given by the user. Workflow diagram. Initially, the model displays two images randomly from the folder that is selected by the user. Later, the user identifies the difference in the images after the model displays it on the screen. Later, the user gives its input to the speech. This input is stored in a variable. After that, the model checks the input and the object. If the input and the object is equal, then the model displays it as a right answer and the bounding box is plotted in the object. If it is wrong answer, the bounding box is not plotted in the object. Coming to the results. Here, the model identifies the objects individually from both the images. If the user gives the input as a motorbike, then the model displays the correct answer and will plot the bounding box. Even if the user gives the input as bicycle, as it is also different, it displays the right answer. The bounding box is only displayed after the model displays the right answer. In the second set of image, if the user gives the input as donkey, the model should display as the right answer. But it is not done. The reason is, as Yolo is pre-trained model, it cannot identify all the objects. So it assumes as donkey and horse as the same animal. Similarly, in the case of zebra and white tiger, it considers as the same animal as it is trained by the model. In order to overcome these situations, we need to train the model with a custom dataset. Here comes the drawback. This application is confined to recognizing just 80 pre-trained class objects. Due to this drawback, the model can only identify 80 objects. So, if we give the model a different object, it cannot identify so. The fundamental disadvantage of this application is that it wrongly recognizes an object of underdeveloped classes as one of the pre-trained objects. This presentation extends an outline of the working of Yolo algorithm for object recognition. This presentation likewise centers around identifying objects in image using Yolo v3. The diverse object present in the main image will be represented by the bounding box. Non-maximum suppression recognizes the bounding box with the greatest confidence values. Object detection is one of the most demanding tasks in computer vision. It involves in finding the type of object and knowing the location in the image. Through object detection, we can achieve both object detection and tracking, whereas object tracking generally locks the moving object. However, Yolo is one of the top algorithms for object detection. It gradually increased its accuracy with version updates one by one, which helped it to become the best algorithm. Future scope. This application can be utilized for distinguishing the differences between two images. This can be created to distinguish similarities among images. This can additionally be created to recognize objects in the crime location examination. Yolo v3 algorithm can be utilized in issues like security, observing traffic, etc. And the best example for object recognition is used in self-driving cars. This execution can additionally be scaled to distinguish between different custom objects. The object detection techniques is very useful in solving real-life problems, and many predictions can also be made using these techniques. This can also be used in manufacturing industries by using an additional hardware component like sensors and etc. Thus, object recognition can be really helpful in many situations and solving the real-world problems. Finally, I would like to thank once again organizers by providing a great opportunity to showcase our work. Thank you all.